Okay, 2.4 is all about the real zeros. So the big emphasis here is we have the rational root theorem, right? So it says when a polynomial function is written in descending order of exponents and it has integer coefficients, that any rational zero must be of the form plus or minus p over q. So when we say, hey, p is a factor of the constant terms and q is the factors of the leading coefficient, we're going ahead and finding those and then dividing those two. So if we look at example 1, we're finding all the possible zeros of this polynomial. Our leading term is this first 6x cubed, so the 6, right? And our constant is the negative 15. So let's start with, in this case, the constant comes on top. So you're saying, what are your factors, right, of negative 15, right? And we're going to divide that by your factors of 6. So you're like, okay, well, what multiplies to 15? I can do plus or minus 1 times 15. I could do plus or minus 3 times 15. 5, right? So I got 1, 3, 5, and 15, basically. As long as you have the plus or minus at the end, it's not the end of the world if you don't write it right here at the beginning. Okay, with 6, do the same thing. Well, you've got 1 and 6, you've got 2 and 3. So 1, 2, 3, and 6. So now for all the possible zeros, right, we're going to go through I usually go through the top list and divide it then by the whole top list by one of the numbers on the bottom. So like, hey, what's 1 divided by 1? Well, we get plus or minus 1. What's 3 divided by 1? That's 3. What's 5 divided by 1? That's still 5. What about 15 divided by 1? That's 15. Now let's do the whole same thing, whole top row divided by 2. We'd get a half, right? You get 3 halves, you get 5 halves, and you get 15 halves, right? You keep going, and now we do 5. So we get 5 divided by 1. We do 5 divided by, 1 divided by 3. My bad, 1/3. 3 divided by 3 is still 1, so we have that. We don't need to write it again. But we do not have 5/3. 15 divided by 3, once again, 5. We already have that. Now divided by 6. 1/6. 3/6 is a half. We already have that. We don't have 5/6. 15/6 is 5 halves. We have that as well. So here are all the possible zeros. Okay. Now we're going to kind of put this idea together. We can find our possible zeros. We can actually use those to find our actual factors, and then we're going to graph it like we did in 2.2. So here in this case, we're looking for the possible ones of 3, which is just 1 and 3, divided by the possible ones for 2, so 1 and 2. So here our possibilities are 1, 3, 1/2, and 3 halves. Sorry, I'm not saying plus or minus, but yes, it is plus or minus, right? Okay. When they ask you to find all the zeros of that polynomial, in this case, they're like kind of asking you to use our skills we learned last time and use synthetic division to find some of those. So like, you're like, hey, maybe I'll start with 1. And then you take your coefficients. If you want a quick way to self-check, do you remember what I said before about like, hey, actually this may be a little quicker. Like if you plug in 1, whatever you get out, it should give you 0 if it doesn't have a remainder, right? So here this would be like 2 minus 3 minus 8 minus 3. And that's definitely some negative number. In this case, what is that? Negative 14 plus 2, negative 12? So like that's not actually a 0. So maybe you try another number, like, well, negative 1 then a lot of times works. A lot of times we start with 1 or negative 1, and you usually get lucky, but not always. 2, negative 3, negative 8, negative 3. So I bring down the 2. 2 times negative 1 is a negative 1. We get negative 4. Negative 4 times negative 1 is 4. I messed something up here. I sure did. I wrote a negative 1 there when it should have been a negative 2. So now this is negative 5. This is looking better. Negative 1 times negative 5 is 5. we get a -3, we get a +3. Hey, we get a 0. Good sign, right? So we know 1 0 is x equals -1. For the other ones, as soon as you get a quadratic, you don't need to waste your time with synthetic division. We know how to solve quadratics like the back of our hand, right? A lot of times, so we'll say what multiplies to -6 adds to -5. We get -6/1. So 2x squared minus 6x plus 1x minus 3 equals 0. Do your grouping. You get a 2x, we get a 1. 2x plus 1 goes in one set. X minus 3 is the other, which means these two zeros are x equals -1/2 and x equals 3. So, hey, for my x-intercepts here, I've got x equals -1, x is -1/2, and 3. All of those have multiplicity of 1. And the reason I bring that up is because we know that at those points it's going to cross. It's not going to bounce. The other two things I usually tell you to look for is you should also know the y-intercept. So if you plug in 0 for x, or if you just look at the constant at the end, it's -3. And then last but not least, we should look a little bit at the degree. So it's degree 3, and it is positive because it's got that coefficient of 2. So therefore, we know it starts low and ends high. From that information, that's all they really are wanting of you right now, to go ahead and graph it. So we're going to go ahead and plot these points. And we know, hey, if it starts low, it's going to go down, up. It's going to cross through that y-intercept, come back around. As long as it's somewhere like that, it's okay if you have it a little bit deeper, a little bit wider. In general, though, it will have like a turning point kind of halfway between the x-intercepts. All right, we put ideas from 2.2 together with ideas from 2.4. We now have kind of two more graphs for us to look at. Let's do, now we can do both these. Okay, so then same thing. We got to find some zeros. In general, particularly when I give you something like degree 4, like example 4, I usually will tell you maybe the first 0. So like for example 3, maybe I'd be like, hey, x equals 1 is a 0. So if I tell you that, all of a sudden, then you will get down to a quadratic once we do our synthetic division. So let's do our synthetic division. And we do get a 0 there. So we're left with x squared minus x minus 6 equals 0, which is x minus 3, x plus 2 equals 0. So x does equal 3 and a -2. So our x-intercepts are 1, -2, 3. Our y-intercept is the constant, right, when we plug in 0, so we do get 6. It is a degree 3 again, and it is positive. So we start low, we end high. Meaning, if you want the fancy way, the limit as x goes to infinity, so on the right, is going to be that f of x does go to infinity as well. And the limit as x goes to -infinity is that our y values are also going down to -infinity. Okay, so we got a -2, we've got a 3, we've got a 1, we got a y-intercept of 6. Start low. Oops, sorry, that wasn't the best. Start low. End high. It's like playing connect the dots. Okay, on this next one, we got now a quartic. I will tell you right now, I mean, you could look at it and think, well, hey, it's got to be factors of 8, basically. So plus or minus 1, 2, 3, 4, and 8. Here, I will tell you, hey, x equals 1 has a multiplicity of 2. Just mostly I tell you that, particularly when you have like a test or a quiz, because I don't want you to sit there and spend hours plugging in different values with synthetic division. It's just not worth either of our time. So let's plug in 1. So we've got our synthetic division. We get 1 again. We get -1. We get -8. We get 8, and we get 0. Looking good. That is a 0. Okay, same thing. 1, we get 0. We get 0, we get -8, we get -8, we get 0. Looking good. So the quadratic I'm left with is x squared minus 8 equals 0. And you may recognize, hey, 8 is not a perfect square. I can't factor that to like x minus 3, x plus 3, right? That doesn't quite work out. If you have just a squared term, though, I always think it easier to move the constant to the other side, because then all I have to do is take the square root. Just remember, it does need 2 answers, so x equals plus or minus the square root of 8. You can simplify that if you wanted, right? 8 breaks down to 4 and 2, which breaks down to 2 and 2, so plus or minus 2 square roots of 2. And if you're curious, that's approximately -2.8, so when we graph it, we'll kind of know where that is on the graph. Okay, so our x-intercepts, we got x equals 1. But this does have a multiplicity of 2, so remember that means that it's going to bounce there. And then you've got x equals square root of 8. I'll say the 2 square roots of 2. Those two are equivalent, though, or -2 square roots of 2. And both of these are multiplicity 1, right? So that means it's going to cross. Okay, your y-intercept is a -8. This one is a degree 4, and it is positive. So this time they'll actually both go up at the end. Okay, let's do it. We got this. We've got a 1. We've got 2.8, which is going to be really close to 3, and really close to -3. And I've got a -8. So we are going to start at the top, come down. Oops, I messed that up already, or it's bouncing at 1. Start at the top, come down, bounce at 1, go back up to end us off. All right, good luck with 2.8.